doing his intro stuff. I might as well do my own intro stuff.
I thought we were going to talk smack about Alan.
Well, I'm live already, so that's a perfect opportunity to talk smack about Alan. About how he couldn't redshift a blue shift.
I heard he blue shifted your mama last night.
Rough.
Oh, no, he didn't.
No, he didn't. And yeah, that's, things are going to go down. So he's running his intro, and we'll do the proper introduction to reading night once he comes back. For those of you tuning in on Ether Cosmology, I should have had an intro prepared, but I didn't. So, alas, here we are. Yeah, what's up, Ken?
What up?
Not much, just waiting for Alan to get back so we can run through the intro here and start doing some reading.
Sweet.
Oh, dog sounds pumped too.
Yeah, there's a cat.
All right. Toby, we're live.
Alright, so there is a cat in the Redshift readings in outer space from the, I don't know. The Redshift is referring to Seeing Red by Halton, because tonight is reading night number 20. 20 nights, 20 weeks straight of just reading, and that's not including random other nights when we got together and read, and the 3 times we got together just to read Brenner comps, and other times when we just pull up papers to discuss them. So 20 weeks of reading, maybe more like 25, 26. Not to mention, you go back through the old Space Audits archives, you'll find our boy Alan just plugging away through Adatovsky's Ether Dynamics. The AI translation directly from Russian. And that was actually part, I think, of what started this whole channel becoming what it is, was Alan doing that. And then now we do reading every week. So there's a little story from how you get from 0 to 20 of reading night. In any case, the classic disclaimer I always say on reading night is that we aren't here to put a little shirt on for you or to make this, palatable. This is literally us coming together and reading, although right now we are reading from Halton, and the book has been, fairly palatable. It's not too technical. It's more of a story than it is actual hard science. So kind of just his narrative of his biography, his experience with observing Redshift and coming to simple conclusions directly from the evidence, and then being essentially kicked out of academia for it and be taken away. Well, can't look at the sky anymore. We're going to take away your ability to use observatories because you don't think that we're on a spinning space ball.
It's best taken in with a light Sauvignon, and if you have to venture as far astray as the Zinfandel, we will not think any less of you.
Exactly. Right?
Well said, man. It was a real shame when you got to take a man's ability to look at the sky just because he has credentials and the things he might say, might give weight, or, might have weight behind it. Because that's the whole thing, right? Is this illusion of, all these guys got together when they look at the sky and they agreed on what they're looking at. And then some other guy comes along and he's like, hey, you guys are doing this wrong. This goes against what you're saying. And they literally got together and were like, yeah, we're going to go ahead and just disregard what you're saying, though. Like, that's crazy, man. Because this isn't a field where you can do experiments and manipulate variables and stuff, really. You're just kind of looking at the sky and making broad assertions about about the story about the story regarding the frequency that you measured, right? You're like, oh, I measured this frequency. How did that happen? Well, what happened was this quasar from 68 billion, no, like, none of that's on the table when you take that away, because it's not built on anything. It's just all assumptions. So if you come across something that refutes that, observationally, then it's just as valid, right? So they can't have any dissent. So what we're looking at is kind of like a historical archive of one man's, it's like, oh, where's the whistleblower? Where's the guy that did the, how come nobody, or wouldn't they all have to be in on it? Like, well, what happens when somebody goes, like, this is the story of what happens when the guy went against it, right? Or tried to. Shout out to your boy.
Oh, yeah, that's trying.
No, you're good.
I can imagine how that first conversation went. He comes in and he goes, "What's up, guys? I think you might be doing it wrong. And here's why." And then they just go, but have you considered nuh-uh? And then he's like, what? That's not an argument. Nuh-uh. And then they will just start going nuh-uh, and like 10 of them.
Well, dude, so he actually commented and was like, it's the highest form of argument, and it's reserved for, like, the ultimate end-all be-all is that they can all just get together and do a group nuh-uh, and that's it. So, like, that's crazy, dude. But anyway, let's continue on with the story here.
Cool. So, yeah, I can go and get us started tonight.
All right,
That works for everyone else. So we left off on chapter 2, because intro was, essentially a full chapter. And we knocked that out last week. And then, even though this is night 4 or 3 of reading this, what up, Shane? Even though this is night 3 of reading this, the first night we were reading it, we started like halfway through. So we read specifically a bit about the Einstein cross and some stuff around that. So, in any case, let's go ahead and jump into chapter 2.
Very seldom is it appropriate to be an out-thinking game, so.
Yo, what up, G?
What's up?
So, chapter 2, Safer Galaxies as Quasar Factories.
Nice.
Evidence that quasars were physically associated with low redshift galaxies had been amassing since 1966. See Quasars, Redshifts, and Controversies for the history through to about 1987. The following years saw further proofs accumulate, mostly from X-ray observations, and they are reported now in the previous chapter. But the stronger the evidence, it seemed, the more attitudes hardened against accepting those observations. With the discovery of the pair of quasars across NGC 42858, however, a new level of proof suggested itself. If more such striking pairs across active galaxies could be found, it would be hard to resist the ultimate conclusion. What more obvious class to inspect than those like NGC 4258, namely Seifert galaxies, or Seifert galaxies. Seifert galaxies. The American astronomer Carl Seifert discovered this class of galaxies in the 1950s by looking at photographs and noticing that some galaxies had brilliant, sharp nuclei. The emission line spectrum of such a galaxy signified that large amounts of energy were being released into its nucleus. For a long time, no one was worried where this energy came from. When the problem was finally realized, accretion disks came to the rescue, a kind of cosmic equivalent of throwing another log on the campfire. But the conspicuous emission lines did not enable astronomers to do something that they are good at, systematically classify and catalog these effects. Since Seifert galaxies produced strong X-ray emission, by 1995, most of the brighter ones had been observed with the Rosat satellite. This presented an opportunity to investigate a class of active galaxies which had been previously defined and more or less completely observed. The existing observations could be analyzed to see whether there existed more cases of pairs of quasars across active nuclei, such as had been observed in the Seifert galaxy NGC 4258. A search through the archived X-ray observations revealed that, of all Seiferts known, observations were 74% complete to 10th apparent magnitude and 50% complete to 12th. after some contaminated fields had been weeded out, a total of 26 fields were available. Now came the formidable task of accessing and analyzing these fields. As mentioned previously, an enormous amount of specialized knowledge is required to enter the quote-unquote public archives. I found the perfect candidate to collaborate with me on this job, a German astronomer named Hans-Dieter Radek. He had just finished doing a very important and courageous piece of work on the gamma-ray observations in the region of the Virgo supercluster, which we will discuss later. But he was out of a job, and the problem was to find him some funding. It seemed hopeless. But as a last resort, I asked Simon White, our new director at Max Planck Institute for Astrophysique, MPA, if he could help. To our delight, he found support for 6 months, and this made possible what I will be recognized, or what I hope will be recognized as a crucial step forward in our understanding of physics and cosmology. Heinz Dieter produced lists of sources, their strengths and positions for each of the 26 Seifert fields. Then, using exactly the same detection algorithm, he reduced 14 control fields. The control fields were within the same range of galactic latitudes and treated identically to the Seifert fields. Therefore, when a significant excess of X-ray sources was found around the Seifert galaxies, there was no question that these X-ray sources belonged to the active galaxies. The sources were 10 to 100 times more luminous than sources usually found in galaxies, such as binary stars or supernova remnants, and they lay far outside the confines of the galaxy, generally from 10 to 40 arc minutes away or several hundred kiloparsecs at the average distance of the Seifert. Practical experience guaranteed that these kind of X-ray sources would be confirmed as quasars. The beautiful feature of this research was that any astronomer could simply look at this one plot of X-ray strength versus number per square degree, as shown in Figure 2.1, and realize that when these excess sources, which manifestly belong to Seiferts, were measured, they would almost all turn out to be quasars. With one economical diagram, we had proved the Seifert galaxies as a class were physically associated with quasars. This added enormously to the significance of the pairs of Seiferts such as NGC 4258, because now in the data we're just telling us in what way the pairs were related to the active galaxy. In later sections, we will discuss the obvious relation of the quasar pairs to pairs of radio sources which, since the 1950s, are acknowledged to have been shot out of the nuclei of active galaxies. Of course, in this sample of 24 Seiferts, omitting the brightest two as being too close to fit into the average sample, see Figure 2.2, many more pairs of X-ray sources were found. All told, there were 21 pairs of X-ray sources involving 53 BSOs. Some pairs of alignments involved multiple X-ray sources. Almost every Seifert had a pair of blue stellar object, most of which were certain to turn out to be quasars. Before we discuss some of these new pairs, however, it is interesting to comment on how these developments were received. Spreading the good news. So that sounds like a ironic title. Astronomers are always holding meetings, and as the journals became choked with papers, the meetings are increasingly the forum where the new results are communicated, except for press releases, which are so hyped that they have been heavily discontinued. The meetings are traditionally the places where power relations are straightened out. It is painful for me to attend them because there is almost total conformity to obsolete assumptions. But I am old-fashioned enough to believe that when truly important new results come along, the conference organizers have a moral obligation to see that the results are presented. With the new results in hand, I became optimistic that they were communicated. When they were communicated, they would finally persuade the researchers to at last begin to reappraise the fundamentals in the field. Many of the new results discussed in Chapter 1 were available at the time of the well-known Texas Symposium on Relativistic Astrophysics, which is held in the adjacent institute in Munich in December of 1994. I submitted an abstract of a paper I wanted to give. The schedule was released, but my name was missing. About 14 years previously, the Texas Symposium had been held in Munich, and I traveled all the way from California to give a summary paper on the evidence for associations of quasars with the low redshift galaxies. The paper made some impression then, but now I was sad to say, after all this time, when the evidence had grown so much stronger, the newest evidence was not to be allowed. Sometime later, an international X-ray conference was held in the nearby town of Wurzburg. Again, I was excluded. Finally, in 1996, I was awarded an eminent scientist invitation to come to Japan for 3 months. It was suggested I could time my visit with an international conference on X-rays that was going to take place in Tokyo. The new results on the families of quasars around Seyferts were just out, so I sent in an abstract and arranged to come during that period. I was really joyous at the thought that this important information could be communicated in these circumstances, and that some sort of reconciliation could take place between people who were really interested in advancing knowledge. Just as I was packing, the conference schedule came out without my name on it. Now I'm experienced enough to know how organizing committees pick speakers for conferences, and I have a rough idea of who, particularly in the most advanced countries, exerts pressure to keep what they consider rival research off the programs. But I am extremely saddened to realize that the members of the local organizing committees give in to such imperialistic pressure. Wow. So there you go, spreading the good news. Shut down over and over and over again.
Straight blackballed them.
That's crazy. A striking new pair. It was exhilarating just to scan through all the new, good-looking pairs of X-ray sources across the Seyferts in the maps obtained from the archives. A sample of these maps is shown here in figures 2, 3, 4, and 5. Note that the X-rays are plotted just as received and not averaged to give their mean position, which is on average accurate to a few seconds of arc. Even though the images enlarge as they occur further off axis, their disposition with respect to the central cipher and the relative X-ray brightness of the sources are conveyed very clearly. Which one, Stone? Which one's your favorite?
I'm going to have to go top left. It looks like a defensive pattern.
Okay, I like it. Symmetry, you're a symmetry guy, huh? Alright. So, an outstanding pair was immediately noticed across NGC 2639. The two X-ray sources were both very strong, 26 and 38 counts per kilosec. The identifications with BSOs were accurate and unambiguous. Actually, one was a cataloged quasar that I had discovered near a companion to NGC 2639 in 1980. Again, there was the need to get a spectrum of the other member of the pair, again, Margaret Burbage, to the rescue. That pair of redshifts turned out to be a lift-you-out-of-your-chair thrill. As figure 2.4 shows... Oh, here, we gotta find 2.4. Let's see if it lifts us out of our chair. Here you go. Whoa!
Whoa, dude, that's crazy. Look at that.
Some stunning XEZ stuff there, man. Wow.
Yeah, whoa. I gotta find my chair. Hold on, guys. Alright. So... that pair of redshifts turned out to be a lift-you-out-of-your-chair thrill, as we all experienced. As figure 2.4 shows, the redshifts were Z equals 0.307 and 0.325, a difference of only 0.018, This was the closest that any of the pairs had been in Redshift. What was exciting about this, of course, was that two unrelated X-ray quasars had only about 1 chance in 100 of accidentally falling this close in Redshift. That probability, times the vanishing probability of finding such a strong pair of X-ray sources across an arbitrary point in the sky, made the whole computation a waste of time. Here was clearly another physical pair across a Seifert. Fainter sources can be seen in Figure 2.4, aligned opposite to the Z equals 0.307 quasar and extending toward the Z equals 0.325 quasar. With fainter isofading on an enlarged view of this region, 4 BSOs are optically identified and clearly represent a trail of quasars leading out to the Z equals 0.325 quasar when confirmed. See later, Figure 326. Another water maser. While the quasar redshifts were being measured, word arrived that stimulated emission from H2O molecules had been observed in the nucleus of NGC 2639, the same water masering that had been observed in the nucleus of NGC 4258. This meant that the two best-known pairs of quasars across the Seifert fell across the Seiferts known to have the strongest black hole activity. The water maser lines in NGC 2639 were particularly variable, showing long velocity drifts of about 7 kilometers per second in a year. Very strong X-ray sources across the Seifert NGC 4235. Catalog identifications of a quasar and a BL lac object are labeled. Plus sign indicates the position of a Seifert, one of Z equals 0.080, identified previously but not registered in the present Rosette X-ray map. I pointed out that the patches of water maser emissions in the nucleus of NGC 4258 were distributed approximately along lines in the direction of two quasars, Figure 1.4 in preceding chapter. So I was very pleased when Margaret and Jeff Burbridge wrote a short paper gathering together all the evidence for NGC 4258, ejecting material in roughly these directions in contradiction to the conventional interpretation, which had the rotation axis of the black hole at 90 degrees to this direction. Following this, another water maser was discovered in the center of NGC 1068. As the lower right-hand panel in Figure 2.3 shows, the orientation of the water masering spots, full line, again points in the direction of a strong pair of X-ray BSOs aligned across the nucleus of NGC 1068. Now, it may turn out that masering activity is common in Seiferts and is ejection activity, but it also appears to be correlated with the strength or direction of the major ejection activity in the galaxy. At the moment, the best guess as to what excites the water molecules is radiant energy in the beam associated with the ejection of the quasars. Why such a quote-unquote cool molecule is present in the very inner regions of such active galaxies may be a more challenging question. Indeed, Mr. Arp.
Like it's probably non-water.
No. A new pair of enormously strong X-ray sources. NGC 4235. Ooh, this one sounds fun. Alright. When I first saw the X-ray map of the field around NGC 4235, I was sure the pair of sources belonged to the Seifert, because the chance of accidentally encountering such strong sources is only about 4 in 1,000. Taking into account the alignment and equal spacing gives us a total chance of the pair being accidental of only 6 in 100,000. But I made a hasty assumption, namely that they were so strong in X-rays that they would be X-ray galaxies. So I only checked catalogs of known X-ray galaxies, and when I did not find them, I assumed they would have to be measured. After the paper was submitted, I stumbled across two sources cataloged. One as a very bright quasar of Z equals 0.334, and the other as a characteristically X-ray bright BL lac object of z equals 0.136. See figure 2.5. The discovery of BL-lac objects in associated pairs is extremely important. We will show in the later sections that BL-lacs, because of their rarity, offer a powerful proof of associations, and therefore of intrinsic redshifts. They will also play an important role in the discussion of galaxy clusters in Chapter 6. The question of ejection velocity. In the first chapter, we stressed the fact that the observations of pairs of quasars allowed us to compute a projected ejection velocity of about 0.07 c. The NGC 4235 pair that just discussed would support this by giving a projected ejection velocity of 0.08 c. That is, the intrinsic redshift of the quasar would be z equals 0.235, where the velocity towards us would subtract z equals 0.099, and the velocity away from us would add z equals 0.099. In Chapter 1, however, we showed one case where the redshifts in the pair were z equals 0.62 and 0.67, yielding a projected velocity of only 0.015 c. The separation on the sky for this case was about 1.3 degrees, about 50% greater than other pairs associated with galaxies at this approximate distance from us. This made it plausible to argue that we were viewing the inevitable occurrence where the ejection was across our line of sight and toward and away from across our line of sight, and the toward and away components of velocity were much reduced. It was amusing to note that when the NGC 4258 pair was first being discussed in a colloquium, Gunther Hasinger challenged me to predict the redshifts of the probable quasars. The conventionalists clearly wanted a way to wriggle out of having to accept the association of the quasars. When they were measured at z equals 0.4 and 0.65, I was encouraged that they were that close, and that the conventionalists were relieved. That they were not closer. They should not have been relieved, because if quasars had been much closer, there would have not been enough velocity to get them out of the galaxy nucleus. The pair across NGC 2639 at z equals 0.307 and 0.325, however, represents a more interesting situation. That would only allow 0.007 c velocity component in the line of sight. For an ejection at 0.1 c, we might expect to get such an orientation across the line of sight only about 9% of the time, a figure that can only be checked by measurements of many more pairs. But there is another very interesting aspect to this problem. Do the ejection velocities represent a constant velocity of escape which will allow the quasars to pass out into space between the galaxies, or do they decelerate as they reach larger distances from the ejecting galaxy? Do they keep going or stop? Popcorn, anyone?
Yeah, I got you. So the Narlikar-Das model for ejection of quasars. By the 1980s, I had produced strong statistical evidence that quasars were in excess density around younger companion and active galaxies. Janet Narlikar and P.K. Das set out to make a dynamical model which could explain this. The problem was assuming a reasonable property for the quasars to find a way to keep the quasars in the spatial vicinity of the ejecting galaxy. Their model did this very nicely, and the journal is listed below.
Hello?
Yeah, you're good. Scroll down.
You had it. Keep scrolling down there. That's good.
Thank you, sir. One quantitative prediction of their model was that the quasars would reach a maximum apogee from the galaxy of about 400 kiloparsecs. Now, it's very interesting that at the redshift distance of NGC 2639, the two quasars are just about 400 kiloparsecs from the Seyfert. This would mean that the ejection velocity would have been lost and the quasars would be moving very slowly. Therefore, the quasars at the distance from their galaxies of origin might be expected to have a more closely matching redshift regardless of their orientation of their injection direction to the line of sight. Another aspect, which will be discussed in later chapters, is that the quasars probably evolve to lower intrinsic redshifts as they age. In the case of the quasars, the lower redshift would generally be expected to have a smaller component of ejection or peculiar velocity, more like the galaxies with which they are evolving. The Seyfert galaxy NGC 1097. NGC 1097 has the most extensive low surface brightness optical jets of any galaxy known. Plate 2-7 shows the true colors composited by Jean Lohr of a set of the deepest 4-meter telescope plates ever taken at Cerro Tolo, Chile. On one side, just between the brightest jets of the optical, just between the brightest optical jets is a concentration of 5 or 6 bright quasars. These have been shown to represent an excess of a factor of 20 over the expected background values, and about 40 quasars have been demonstrated to be concentrated around the galaxy. Let's see. Figure 2.6 shows that the quasar candidate in the inner 2.85 times 2.85 degree center of the objective prism plate can be taken out by the UK Schmidt telescope in Australia. The Chinese astronomer XT He picked out these by appearance of the spectra. In the 2-year observing program in Chile, I was able to verify with an individual spectra that the accuracy of identification was an amazing 94%. It is important to note that when the considerable work of the number of people that was published in 1983 and 1984, it was already established at the time of the association of
Wow,
I
look
like
at
that
that
one.
one. That looks like
That's
cave
intense.
painting.
That's intense. I think I saw that on the pyramids.
Right, yep. They were trying to tell us about the Seyfert galaxies.
Yeah, I think I can't remember the guy's name. Graham Hancock has a book on that, I think. In 1993 or 94, however, I received X-ray results of my own in the most exciting quasar galaxy association, or galaxy quasar association. The data came from the 3 ROSAT modes. It came in all 3 ROSAT modes. The low and high resolution pointed out the survey modes. The size of the field covered by the PSPC and the HRI in figure 6.2. Let's see, when I reduced the X-ray data, I was at once struck by a large number of X-ray sources in the field. Brighter sources in the NGC 1097 field were more than 50% in excess of the average control fields. The X-ray sources detected by the ROSAT confirmed the earlier observations by the Einstein X-ray Observatory. In particular, confirmed the brightest quasars fell just between and along the strongest optical jets. Since it is difficult not to believe that the optical jets are ejected, it is obvious that the quasars are also ejected from NGC 1097. These observations also showed the lines and pairs of fainter X-ray sources coming out from the nuclear region of the Seyfert in figures 2-7, 2-8, and 2-. That's it. There was a large excess of X-rays and sources coming from the disk region from the galaxy, and evidence for the strong absorption of the soft X-ray component of many of the faint sources, since it is known from optical studies of the galaxies that there is a strong absorption of the disk of the galaxy in figure 2-9, it was reasonable to suppose that the metals in this mixture of dust and gas were dimming the soft bands of X-ray sources. Unabsorbed X-ray sources would be bright enough so that they could reasonably only be quasars. The upshot of these observations suggests that many higher shift quasars are being ejected, and that many of them may be encased in thick cocoons. That's cool. Evidently, this is a busy quasar factory, and it is an interesting place to investigate in the far and infrared, in the far red and infrared fields or spectra. See, we will see later the high redshift quasars, Z equals 2. Dang, that's a high redshift. And there are generally fainter quasars in the Z to 0.3 to 1.5 range. We have, however, already mentioned that quasars appear to be born with high redshifts, which decrease with age. Since many bright quasars with these smaller redshifts are associated with NGC 1097, it is reasonable to suggest that the fainter X-ray sources are high redshift young quasars, many of which are just emerging from the central dusty regions of the Seyfert. For example, the high-resolution X-ray observations, the ROSAT HRI, show a pair of point sources paired across the NGC 1097 nucleus, designated as 6 and A in Figure 2-8. These are not optically identified on deep blue sensitive plates. They probably would be identifiable with the penetrating power of infrared techniques on the new large aperture telescopes. What a useful project for these expensive facilities. Figure 2-8 shows the low surface brightness material extending out from a number of NGC 1097 between the jets to the location to the brightest quasars. It is not clear that this X-ray material because let me start over here and say, where was I at? Let's see. It is not clear that this is X-ray material because it does not show that the more sensitive PSC or PSPC observations is probably more ultraviolet light leaking in the imperfectly blocked filter. This possibility doubted when I first published the evidence, but later a leak was verified that in a measurement of the filter. Wow. In the case of the important aspect of this material, it must arise from some hot gas which is ejected along the quasars. One attempt to get a spectra with the satellite of the Ultraviolet Explorer failed on the administrative air, and another attempt failed when the stabilizing gyro died. In the wide field of the ROSAT survey mode in Figure 2-10, there is a very strong X-ray source A identified at about 1.9 degrees to the southwest. In fact, it is stronger than a very strong NGC 1097 itself. It is identified with a bright, probably stellar apparent object. Tony Farrell, with a 74-inch South African telescope, took a spectrum which demonstrated that it had a blue continuous energy distribution, thus identifying it as a BL-LAC object. It's like, okay. This important kind of quasar-like object will be discussed immediately below, but first I would like to point out the important discovery of the survey X-ray field. As the enlarged figure 1211 shows, the BL-LAC object is on the line of sources southwest from NGC 1097, which coincides closely with the counterjet of the strongest optical jet to the northeast. Along the major optical jet to the northeast, however, is one of the brightest X-ray quasars belonging to NGC 1097. The X-ray isophotes of this quasar extend both backwards and forwards along the lines of the optical jet, of the strongest optical jet. Since this alignment is obviously not by accident, and since the optical jet is obviously originated by ejection from the active nucleus, this is another proof that the quasar must also have originated by ejection from the nucleus. Moreover, the strong X-ray BL-LAC on the other side of the nucleus must then represent the other component of the ejected pair. The Empire Strikes Back. Since the NGC 1097 paper contained tables of the new source identifications from this analysis of the three different fields field-sized, centered of important Seyfert galaxies NGC 1097, I thought it would be routine to publish in a journal which was carrying the most of the European X-ray results of the archive value. I was how I was wrong, or how wrong was I? The referee's report came back accusing me of manipulating the data and trying to claim associations of the quasars and galaxies, which which had long been disproved. The editor, dude, that's the old thing. We have the new thing. You can't go back.
Doesn't it just feel like we're just reading our life story? Like, I mean, it's just all so exactly, like everything is exactly what we experience. Just
It's
the
very
gaslighting,
reminiscent.
That's just proved, that's debunked forever ago, you stupid. Man.
Oh, all these match up? No, that's debunked forever ago. Okay, dude, cool. So the editor forwarded the comments and rejected the paper on the grounds that he saw no need to reopen the debate. Case closed, right where we found it. All right. So the extraordinary aspect of the 4 papers, in addition to my own, had just appeared in the same journal, giving strong evidence for such associations. The figures appeared for the first time, and the tabular X-ray data is still unpublished. World first, boys. We're getting the first people to look at it. All right. BL-LAC objects. These objects are named so because the prototype was originally classified as a variable star within our own galaxy. But then it was discovered that in many cases, faint redshifted lines could be detected on the strong continuum spectrum. Often these objects would show faint nebulous edges on their images. The BL-LACs are now known to be strong radio and X-ray emitters, and are strongly variable. They are also, let's see 1 second. They're also rather rare, and when they showed up in the Rosat Seyfert field, they were very conspicuous because of their strong X-ray emissions. Figure 212 shows an example of the BL-LAC object close to the grand design spiral Seyfert NGC 101365. While I was inspecting the 26 Seyfert archival fields discussed earlier, it was clear to me that the number of such objects encountered was significantly higher than to be expected in the non-Seyfert fields. There are no real need to compute the probabilities, but it can be done simply enough. The probability of encountering X-ray BL-LACs is this bright is close to the Seyfert, ran from about 10 to the minus 2 to 10 to the minus 4. See tables 2-1, 2. 2-1. Therefore, the chance.
I mean, that one's pretty cool. Look at that. Almost looks like a funny little face. Wow.
I just made the one on the left my wallpaper.
Nice.
It's sick, dude. And it's my profile pic on Twitter now.
I'm going to put together just a nice slideshow and we're all done with some pretty piano music.
Of encountering the first 5 was about 3 times 10 to the minus 5, and if we could count the object near NGC 3516 as a BL-LAC, a chance of only about 3 in 10 million. A referee argued that due to the uncertainty density of the brightness of BL-LACs, this probability was uncertain, thus disproving the association. Dang. Referee got him again, boys. But even if it were only 1 in a million, the results are overpoweringly significant. Moreover, the finding is restricted to the just 5 clear-cut BL-LACs encountered so far, and more are indicated in the full sample of 26. Ridiculous, snorted the conventional astronomer who would have believed a probability that small, right? What is wrong? Well, it's a posterior. What do we got? A posterior?
A posteriori.
A posteriori. Thank you, sir. Well, it's a posteriori computed after you found the effect. So let's throw it out. But along came the great stroke of good fortune. In 1979, Jack Solenik, thank you. Jack Solentic and I had tested the proximity of the then known BL lax to the bright apparent magnitude, shapely Ames catalog galaxies, and found an excess of the separation of about 1 degree. The same as in the Seyfert fields. So the Seyfert results was not a posteriori, but a confirmation of a previously predicted result. The cautionary lesson here seems to be no matter how significant the result, it must be customary to try and invent a reason to discard it if it does not fit the expectations. Can we get a highlight? Thanks, sir.
Can I get an amen?
Yeah, dude. In the game here, the game here is to lump all the previous observations into one quote unquote hypothesis and then claim there is no second confirming observation. Very nice. But most important of all, does this result make sense? It does, and in fact, it is expected on empirical grounds. Consider one of the quasars in the pair associated with NGC 2639, which we just discussed. Its apparent magnitude was V equals 18.1 magnitude, and its redshift was Z equals 0.307, compared to the BL-LAC object with a 12 arc minute of the Seyfert. Or within 12 arc minutes of the Seyfert NGC 1365, the BL-LAC object had an apparent magnitude of V equals 18.1 magnitude and Z equals 0.308. And the X-ray flux of the quasar was strong, but the flux of the BL-LAC object was 3.5 times greater. Undoubtedly, the signal of the strong non-thermal continuum, which reduces the spectral line characteristics of the BL-LAC objects to a low
Contrast.
Continuum?
Man.
Oh,
man. Thank you. I couldn't get it. Contrast. All right. And let's see. But the BL-LAC objects are notoriously variable. The implication then is that the BL-LAC can turn into a quasar quite easily and vice versa. Since they are already very similar, the key point here is that the BL-LAC objects are kind of rare and are kind of a rare quasar which can be easily recognized by their strong X-ray emission. Therefore, they are easily proved to be associated with the active galaxies, confirming the proofs of the related kinds of objects to the quasars are also associated. Dang. So it is interesting to inspect the neutral hydrogen map of the grand design barred spiral NGC 1365. Figure 2-13A shows the optical photograph. Figure 2-13B shows how the hydrogen concentrates in the spiral arm of the spiral arm to the southwest of the galaxy. Let's see. One can see the multiple ejected arm to the north of the galaxy, which at a glance disposes of several decades of density wave theory of the formation of the arms. Dang. But in figure 2-13C shows that the hydrogen is extended closely to the direction of the nearby BL-LACs, or BL-LACs. In the following NGC 4151, we will actually see a connection to a BL-LAC. Very nice. The Seyfert galaxy, NGC 4151, another famous and extremely active Seyfert galaxy, NGC 4151. This is one of my favorite ones. Like my family would always tell stories about this one growing up.
Oh, you guys were an NGC 4151 family, huh?
Yeah, like we don't like to talk about it much, but yeah, we were super into it. It
Nice.
was a lot of radio emissions.
Nice. Yeah, we were 1685. Nice.
Oh yeah, it's not bad. Let's see here. So a map of it and the surrounding companions showed in figure 3-18 in the next chapter. Presented here is the X-ray map of in figure 2-14, which shows that there is a line of the X-ray sources stretching through the central active galaxy to the north, northwest, and to the south, southeast. And to the to the north, northwest are rather strong at 16.0 and 16.2 counts per kilosecond, but they are relatively defocused at 33.1 and 33.9 arc minutes from the center of the field. They are therefore rather spread out. Now, let's see. Yeah, now they and the sources opposite of them, 14.3 plus 9.1 and 35.1 counts per kiloparsec or per kilosecond, are identified with the blue stellar objects, the BSOs. Therefore, we have a case of two highly probable pairs of quasars aligned with a line across the Seyfert. Both are aligned with a fairly close and in the same direction. One might consider one ejection with a narrow opening cone angle. Very nice. And we got our nice black and white. Along this line, about 4.5 arc minutes northeast from NGC 4151 is a powerful X-ray source measured at 257 counts per kilosecond, compared to the Seyfert itself at 750 counts per kilosecond. This is a BL LAC object. It is the one falling next to the Seyfert NGC 1365, or falling next to the like the one falling next to the Okay, it is very unlikely to have been encountered by chance. In this case, the probability is only 2 times 10 to the minus 5. See table 2-1. But the object is also very unusual in that it was first discovered in the radio mapping of the environs. The old environs of the nearby. What the heck is an environs?
The nearbys, the proximals, the next twos, the environs.
Mapping of the environs, okay, of the nearby bright galaxies by the Westbrook telescope. Jan Ort, shout out to your boy Ort from Ort Cloud. Jan Ort had urged this project to me in collaboration with 2 Lindman radio astronomers, Tony Willis and Hans D. Reuter. We had identified this rather strong radio source in NGC 4151 in the NGC 4151 field with a very faint stellar object. It was so faint that I had to use a multi-channel spectrometer on the 200-inch at Palomar for several long exposures in order to try and determine its redshift. I could only register one line and guess that the Lyman alpha at the redshift near z equals 2. That turned out to be wrong, as John Stock and his collaborators later measured an object that had a redshift of z equals 0.615. The puzzle is this. What kind of object would be so faint optically and have such a strong radio and enormous X-ray emissions? As mentioned, it was highly probable that it belonged to NGC 4151, and from figure 4-14, it could be seen to lie within a parent channel from the ejection from that active Seyfert. But there would be an interaction in the X-ray due to the spatial proximity of the strong BL-LAC and the Seyfert. See, by searching the archives, Radek, and I found the HRI exposures of this field, and I set about looking for the outer contours of the 2 images. The outer lower surface brightness regions from NGC 4151 revealed a filamentary extension which connected directly to the BL-LAC object, as shown in 2-15. Identifying the luminous connections between the objects dude, they're all just connected. Is that what he's telling us here?
Yeah, I think that's kind of, yeah.
They're connected by literal filaments. Dude. Identifying the luminous connection between the objects of the greatly disparate or
disparate.
Disparate?
Yep.
Okay, disparate. Redshift is a decisive way to establish their non-velocity character, and we have seen in the previous connections of the quasar Mark 205, Mark 474, and NGC 4651, there could be a rich harvest. I don't know. That's my favorite kind of harvest. Crypto's gone. I was going to ask what he thought about a rich harvest of additional information if the X-ray astronomers were able to recognize the increased detection gained from the integration of their data over the extended surfaces. This is related to the old art of surface brightness photometry, but it would require hiring people who were experienced and motivated, or who were either both of those things. All right, anyone want a popcorn?
Sure thing. Finally, we call attention in Figure 216 to the innermost radio structure of NGC 4151. At the high frequency of 5 GHz, the resolution is so good that objects of less than 1/4 of an arc second can be seen emerging on a line or either side of the central nucleus C4. X-rays cannot yield such high resolution, but show extension in the same direction. Some compact high-energy objects are being ejected in opposite directions from this compact nucleus. What else could they be but proto-quasars? Well, they could be ether hot pockets. This ejection directly obviously rotates with time. So, only older ejection tracks would be pointing to outer associated quasars. We will later grapple with the question of what state the matter is in when it first starts its journey, but the important inference for now is that small entities are ejected from the nuclei of active galaxies and evolve into high redshift quasars and allied objects. Like that paramecium right there. Yeah, great. That looks like Ebola.
They all
Minus
look
the
like a
squiggly.
Microscope, yeah.
You're infected, dude. You got 6 months to go. So, ESO 416 G002. During the time, rumors were flying about Wolfgang Piech's pair of X-ray sources across 4258. The inevitable reaction was, well, that's just a curiosity. There won't be any more. But in addition to all the other cases described earlier in this chapter, in his own programs he had observed several other Seyfert galaxies which turned out to be just as devastating. One is shown here in 217. There are only 3 strong X-ray sources in the field. The source in the center is a Seyfert with Z 10,000 kilometers per second, and the 2 others, almost exactly paired across it, are accurately centered on stellar-appearing objects. Somehow, after more than 2 years of constant effort, it was never possible to obtain their spectra. Perhaps that speaks more eloquently than any further comment that could be made. Recently, Piech with collaborators confirmed the weaker of the pair as a quasar of about 0.6 and the stronger as a BLAC object. Other examples. Now that the Seyfert galaxies have been identified as quasar factories, it is easier to look back and recognize all the other Seyferts which in the past were found to be the origin of associated quasars. Of the first 2 quasars to be associated with the companion galaxies, see that 220-223, the quasar in 5689 group turned out to be associated with the Seyfert Mark 474 back in Chapter 1, and the quasar in the NG 7171 group turned out to be associated with a Seyfert. Mark 205 is technically a Seyfert, although it is often called a quasar. PG 1211 plus 143 is arbitrarily called a quasar, but very similar to Mark 205 because it has redshifts of 0.07 and 0.085 respectively. There is a quasar, GCO248 plus 430, which, if you are ready for this, is described in the literature as a possibly microlensed quasar behind a tidal arm of merging galaxy. The galaxy turns out to be a Seyfert 3, and the quasar has a redshift of Z 1.31. Many more of these galaxies associated with quasars may well turn out to be Seyferts when people get around to measuring them. This is not to say that only Sieverts eject quasars. Some good examples of starburst galaxies give rise to quasars that are NGC 520, M82, NGC 3067. But then, starburst galaxies are closely allied to Sieverts, and the classes may evolve rather rapidly. There's also the probability that outbursts occur intermittently, and after a galaxy has released some quasars, it may become quiescent. It might even vote Democrat. An example of an unworked gold mine is the starburst galaxy 7541, described by ARP in the 1968 Astrofysica article as being a pair of bright radio sources. It subsequently turned out to have quasars of 0.22, 0.62, 1.05, and 1.97 around it. From the Rosat survey, it has a pair of X-ray sources across it, and radio measurements to fainter levels show additional radio sources closely grouped around it. The main galaxy has a straight spiral arm, which looks like an ejection and has an early type stellar absorption spectrum. A close companion galaxy, NGC 7537, appears active and might well be a Seyfert or allied type. This is the kind of region which requires a thorough observing program, the kind of program that used to be possible in the era of small telescopes, but is unthinkable in the era of big telescopes. Summary of the empirical. In spite of a deliberate effort to avoid them, a large number of cases of quasars, undeniably associated with much lower redshift galaxies, have accumulated. Based on the discussion of the first two chapters of this book, the unavoidable conclusion, stated as simply as possible, is this. It is clear that spectroscopically a quasar looks like a small portion of an active, Seyfert-like nucleus. That supports the conclusion from their ubiquitous pairing tendency across the active nuclei that they have been ejected in opposite directions from this central point, which shows similar physical conditions. As explained in the introduction, starting in about 1948, it has become an article of firm belief that galaxies eject radio-emitting material in opposite directions. The quasars often show radio emission, as well as the other attributes of matter in an energetic state, such as X-ray emission and excited optical emission lines. The only possible conclusion from this observational evidence is that quasars are energized condensations of matter, which have been recently ejected from active galaxy nuclei. We will see later, however, that it will be necessary to consider the quasar to be made of more recently created matter in order to account for its higher intrinsic redshift.
Intriguing.
Terminology. It is interesting to recount how the current confusion between some Sieverts and quasars came about. When the luminosities of quasars were computed on the assumption that they were at their redshift distance, it turned out there was a continuity with galaxies in that parameter, as well as other properties. Malt and Schmidt decided that MV minus 23 in a magnitude, I guess that's a magnitude view, was about bright enough for a galaxy, and that anything brighter than that should be called a quasar. Of course, it turned out quasars are actually fainter than galaxies and should be classified on the empirical criteria of compactness and spectral excitation. Another example of the penalty people pay for not using operational definitions is the term AGN, active galaxy nuclei. Once, as I was stepping onto a plane in Santiago, heading back to Pasadena, I met Bruce Morgan coming the other way for an observing run in Chile. "Oh, Chip," he enthused, "I've just decided the new terminology for all these objects. We're going to call them AGNs." He was using his theoretical knowledge that quasars were enormously bright nuclei of enormously distant galaxies. "Absolutely terrible," I replied. "If you do that, you'll wreck the empirical classification." Eventually, everyone came to believe that quasars had host galaxies. John Hutchings, Susan Wyckoff, Pete Wagner, others found host galaxies. Assuming the quasars were at their redshift distances, they found host galaxies that were too big, and some examples that were too small. This is like Goldilocks. Taking a mean, they reported that their porridge was just the right temperature, and their sizes were just right. When the Space Telescope started taking high-res pictures of quasars, you caught that, did you? John Bacall called a press conference to report that a number of them did not have any host galaxies at all. Gasp! Naked quasars! I told you this was astronomical porn. Anyways, the community was horrified. What was going to sustain the enormous luminous output of distant quasars if they didn't have a host galaxy to fuel them? Private meetings were held immediately, and it was rumored that incorrect image reduction was involved. The judgment of doom. The irony here was that Bacall had been coming on like Genghis Khan, Tamerlane, and Vlad the Impaler to anyone who doubted the redshift distance of quasars. Bacall then produced some quasars with host galaxies, and everyone decided to paper over the issue in public. There was no need for this chaos because the first quasar discovered, 3C4 Matthews and Sandage, 3C273 was only the first to have its redshift determined. Had a nebulous fuzz around it, about 12 arc seconds in extent. At a conventional distance corresponding to its redshift of 0.367, this translated to a diameter of 35 to 70 kiloparsecs, depending on the choice of Hubble constant. That is bigger than the big galaxies we know the most about, like M31 and 81. But many quasars with a Z around 0.3 were observed to have central brightness 3 or more magnitudes fainter than the 16.2 magnitude of 3C48. Observed with seeing better than 1 arc second, many showed no fuzz at all. So any host galaxy would have had to be abnormally small. Figure 218 shows a long exposure of 3C48, not with space telescope, but with a relatively small aperture 2.2 meter telescope in Hawaii and some image processing. It shows that the quasar has slipped completely out of the alleged host galaxy. What a way to fuel a quasar. What's worse, anyone who bothered to look would see that a huge low surface brightness envelope surrounds the pair. The galaxy looks very much like a nearby dwarf. I blame the mother. If scientists had only heeded the words of Percy Bridgman on the necessity, keep going, of scrupulously using operational definitions in science, oh, if only, hey, it would now be natural to describe an empirical sequence of quasar development from initially point-like objects at relatively faint apparent magnitudes, gradually transforming into lower redshift compact objects with fuzz around their perimeters, then into small, high surface brightness galaxies with more material around them, and finally, normal quiescent galaxies. So we're heading off to Calgary to stop the stampede when just the most prominent members of operationally defined classes are known. It is usually easier to see the overall relations between them. 219 shows the Hubble diagram, which I published in June 68. The diagram showed that compact galaxies, morphological transitions between galaxies and point-like quasars, had active Seyfert-like spectra and formed an obvious physical continuity between Seyfert galaxies and quasars. But as 219 shows, this class of objects clearly violated the Hubble redshift apparent magnitude relation. Nevertheless, this very Hubble relation is assumed in order to calculate luminosities for these objects. Then the luminosities are used to reclassify them on the basis of a theoretical property, which leads to the chaos described above. The June paper with an expanded version in July 68, in which I showed more members of these classes which were continuous in color properties as well, and even more conspicuously violated the slope of the Hubble line. But my desperate effort did not even slow down the rush to express all measured quantities in terms of great distances in an expanding universe. The juggernaut has continued to gather momentum to the present day. Spotty, X's and O's. I think X wins on that last diagram. 3C48 is a key to the paradigm. We will show in Chapter 5 that 3C273, the first quasar to have its redshift measured, and on the redshift distance assumption, discontinuously the most luminous, is an important member of the relatively nearby Virgo cluster. But the first quasar discovered was 3C48, and from it one could correctly deduce that it was a very strong radio source and a bright apparent magnitude stellar appearing object. Let's get this cat off my lap. Stretch somewhere else. Go away, cat. You can go play with your sister. One might also suppose that of all members of this class of objects, it was among the nearest to us. Then, if the preceding chapters have any meaning, one would expect a very bright low redshift galaxy to be identifiable as its progenitor at not too great a distance from it on the sky. Now, one of the brighter galaxies in our local group is M33, a companion to the dominant M31. M33 is a companion galaxy with a rather young stellar population, and just the kind of galaxy first associated with quasars. The quasar 3C48 is only about 2.5 degrees away, exceptionally close for such bright objects. Fig 220 shows the configuration with another bright quasar in the region. If M33 were removed to the distance of the Virgo cluster, the angular separation of 3C48 and paired quasars would be 7.1 and 12.9 arc minutes from the galaxy. This is just the range of separations we were finding for quasars at the beginning of this chapter around galaxies which were on the average at just about the distance of the local supercluster center. More Rorschach tests coming up. Here we go. What about the quasar on the other side of 3C48? Its redshift is 2.353, and it is a strong radio source with very bright apparent magnitude of 17.5 for such a large redshift. Further out in this region, in this direction, we see an extension of more high redshift quasars, which apparently belong to M33, as shown in the paper on 72 and 73. But we also know from the just referenced work that the high redshift quasars are less luminous than the low redshift quasars. This supports the surprising result that quasars of redshift up to 1.5 can be seen out to the distance of the Virgo cluster, but quasars of greater than about 1.8 are generally not seen much beyond the bounds of the local group. Actually, the PKS quasar in 220 is probably a secondary ejection. The candidate for the counter-ejection from 3C48 would be a bright BL LAC with a mag of 15.7, no known redshift, at 1 hour, 9 minutes, 24 seconds, and 22 days, 28 minutes, 44 seconds, no, degrees, 28 minutes, 44 seconds, in 1950. Because of the rapid evolution of high redshift quasars, 0.2 or greater, we would expect them to be seen rather close to their galaxy of origin. The latter prediction is forcefully borne out by the 7 high Z quasars around Seyfert 1 galaxy 3C120, which appears to be the closest active galaxy to our own in the local group. Check out page 130. The book also contains a chapter, Distribution of Light, a distribution of high redshift quasars in space, chapter 5, which shows their locations in the local group, with the strongest concentration southwest of M33 in the lower right of 220. Get into the Wayback Machine. In about 1951, I was choosing a PhD thesis topic. I'd been captivated by the early reports of Carl Seyfert's discovery of galaxies with brilliant compact cores. I was particularly intrigued with the fact that these cores were rich in ultraviolet light. I guess I sensed this was where there was some action, some mystery. For a thesis, I proposed to photograph these galaxies in ultraviolet light and see what connection the nucleus had to the galaxy and whether there were any other ultraviolet objects around. Rudolf Minkowski, who was Walter Bade's right-hand man, said that was a terrible thesis and that I would yield nothing. I wound up measuring thousands of little clumps of silver grains, photographic images of stars in globular clusters, in order to calibrate distance indicators in which Bade was vitally interested. 20 years later, I was finding quasars around active galaxies by photographing them in ultraviolet and blue light and taking spectra of those candidates with ultraviolet excess. Occasionally, I would think on those nights, if I had done that thesis, maybe I would have discovered quasars 10 years before they were discovered from radio positions. What difference would it have made to the course of cosmology? Then again, maybe I wouldn't. and then I wouldn't have got the chance to later. Even though the globular cluster thesis work helped lead to derivations of the age of the oldest stars, and hence to the age of our galaxy, Bede was suspicious of my reliability and did not recommend me for a staff position. It was Alan Sandage who successfully pressed for my appointment because he thought I would be a great help in determining the holy grail of the distance scale that was the keystone of cosmology. But when I started having independent opinions about stellar population types that proved too competitive for Alan, and he wanted to get rid of me. Well, that did not happen. He refused to speak to me for 10 years. Later, he began to feel lonely, and we were close confidants for a while. One day, he sat in my office and he said, "Chip, you're the only one I can talk to." Well, it was up and down a lot after that, too. But in the end, regardless of everything else, I felt close to him. Like someone you've been together with through a tough war. It transcends the issues and even the opposite sides because no one else quite understands. Yeah.
There we go. Chapter 2 down. You're welcome to keep going if you would like, Stone, or we can.
No, I'm good for now, man. That was a good span there.
Cool. Yeah. So we're at hour and 20 minutes. Do you guys want to try and make some way into this chapter? Should we wrap it up? What do you think, Alan?
Wrap it up, E.
Cool. I'm down. Cool. Then, yeah, we can go ahead and wrap it up. So we got through one more chapter here of Halton Arp's debunking or seeing red. But yeah, I would say this has been a very satisfying read so far.
Yeah, man, this is hella cool.
Yeah, just crazy how much I can relate with this guy with the way he just can't seem to get anyone to listen to him.
It's also 1 second. Sorry, I had to clear my throat. It's also interesting to see, like, these things that they're out there measuring, they have no idea what they are, obviously, but it's just cool to see that they're all connected. Right?
Yeah, and at
Dude,
redshift values that are symmetric and incongruent with their distances, and yeah.
Yeah, dude, the whole narrative of, dude, they're actually expanding and happened billions of years ago. Like, dude, it's not even on the table, bro. Like, what are you talking about? They're connected, dude. That's fascinating, man. No wonder they had to take this guy's eyes. So, yeah, it's been a great read.
So yeah, we'll go ahead and wrap it up here then. Tomorrow night we have a very special presentation from Mr. Robert Bennett, or Dr. Robert Bennett, so tune in for that. That'll start at 7 p.m. Eastern, 8 p.m. Eastern. 8 p.m. Eastern, it'll be round table number 35, I believe. And yeah, Bennett will be providing that, and that's going to be on Hildegard's model, which is relating to ether winds as a geocentric model. We'll see what he has to say about it. We've been looking forward to this one for a while. He's been working on it for a bit. Oh, also there is a debate tomorrow. Shane will be debating Demon Stride. So that's at
Showdown.
He already rescheduled like immediately.
Oh,
Sorry.
Which
Which everybody seems to do. It's weird, dude. It's like, yeah, I'll do it. And then people are like, hey, what are you doing? Hold on. Let me tell you.
Shoot. So we won't be watch partying that, unfortunately.
Yeah, I tried to move it to like later and then next week's because I want to see Bennett's thing too, mostly. I was like, well, I'm not gonna move it later. So next week, oh, he's busy. Well, then, yeah, that's it, bro. That's the only option because I'm not gonna miss Bennett's thing.
Yeah.
yeah.
Hey, real quick before we end though, does anyone know where I can get some delicious home roasted coffee, like fresh roasted?
Yeah.
I don't want like when I order it, I don't want it to be already roasted. You know what I mean? Like that weak stuff. Like I want the guy that owns it to have it fresh and then start roasting it. Do you know anyone that does such a service?
I just roasted coffee about an hour ago. Yeah, or no, 2 hours ago I finished up. Yeah, I roast on my Weber grill twice a week-ish. And if you want to order, you can go to brushtail.coffee, BRUSHTAIL.coffee. Been doing that for a few years now, and that's just me and my grill and a special motor contraption, and it's always fresh. I've got like 9 or 10 different types, and I just
buy coffee that I like, and I roast coffee that I like, and I can't imagine stopping roasting because I can't imagine drinking anyone else's coffee. So if you're looking for good, fresh coffee, I'll roast it and then ship it. So you're going to get it super fresh, potentially even too fresh. So there you go.
Honestly, I didn't even know what fresh coffee was. I'm not even ashamed to admit. Like, I had no idea what that was.
It's different. It's a different
I
experience.
was like, Dunkin' Donuts isn't fresh? Oh, it's like
different.
10 years old. Oh my God.
You're doing yourself a disservice. If you're buying coffee that has, like, the first big step up is when you go from buying coffee that has a shelf life, like when it has a shelf life date on it, like, oh, best by this date. When you go from that to it was roasted on this date, that's first upgrade, right? Like, oh, this was roasted within like the last month. That's first upgrade. When you go from roasted within the last month to like roasted within the last week, that's when you're in like perfection zone right there. Well, yeah. So, or 1 to 2 weeks is really perfect, honestly. But yeah, so check out brushtail.coffee if you're looking for some coffee. And then also check us out. So yeah, Tuesday is that. And then also on Thursday nights, we always do live X Twitter spaces, of course. Check us out for all of that stuff. And yeah, thanks everyone for tuning in. Thanks for reading with us. If you ever want to come read with us, you can come join us. We have a Telegram server and a Telegram channel and a Discord server. I would suggest to join both, but honestly, we spend a lot more time on the Discord server. But the Discord server can be shut down because Discord just decides it's time to do that. So anyways, if you ever want to come read with us, go to ethercosmology.com. There's a Discord logo on the side, and click on that, and then, yeah, come on over. And thanks, everyone, for listening. Take care.